Hello, this is Elizabeth Pluswick, and today this video will be demonstrating a problem that we went over in engineering economics class around November 17th, 18th, or 19th, depending on what location you're at. So we went over this problem 15.19 at the back of the FE Review handbook that we've been studying. Here's a problem. I'll demonstrate the strategy and the solution. We did go over this one in class, and here you have it again on the video. So that's the problem. Asking for the minimum salvage value that the equipment should be sold for 8 years out in the future in order to make this investment economically attractive. That's going to be a key word right there, economically attractive. What does that mean? All right, so the first thing we have to do in our problem-solving strategy is to lay out the timeline of cash flows and figure out what we're given in the problem and what we are asked to find. So for this problem, for the proposed investment, which is buying a machine, it initially cost $2,000. That already is in terms of P, right? That is P, present value of this potential machine. There are two cash flows. A cash flow in that happens regularly, $650, and a cash flow out that also happens at regular intervals of $300. Plotting these on the timeline, we can see that they happen at the same time, so you can ignore that and just call it a net cash flow in of $650 in minus $300 out equals net cash flow in of $350. That happens once a year for 8 years. Therefore, it meets the criteria for an annuity, and so we'll give it the letter A for annuity. What we're asked to find is the salvage value of this equipment. How much should we sell it for? How much will we need to sell this asset for at the end of its 8-year life in order to make this whole set of cash flows economically feasible? And so salvage value in the future is normally designated with the letter F, future value. Since we're solving for this, I'm also going to give it another letter name because this will end up being in dollars. We have to find a future selling price of this asset. So I'm going to call this quantity in dollars with the letter S for salvage value, and indeed it is a future cash flow. Interest rate for this situation, desired rate of return, required interest rate is 10%, required rate of return in the problem for this company. So again, we have to figure out what the heck does economically feasible really mean. Basically, it means do the benefits equal or exceed the costs? So we can see from our timeline, we have cost initially. We have cost here, but we've netted it with benefits to make a net benefit. So this is a benefit, cash flow coming in the future. Here's a future benefit, the amount of proceeds we get from selling that machine in 8 years' time. That's a benefit. And then our initial cost is here. Benefits here, interest rate of 10%, so we just are left with one unknown here. What does this need to be, this dollar amount in the future, to make it so the costs are less than or equal to the future benefits? So basically we want, do the benefits equal or exceed the costs? If so, then the investment is economically feasible. So how we state this then, in an equation, net present worth, which you want to be at least equal to 0 or greater, net present worth, would mean the present worth of the benefits would be greater than the present worth of the costs. Using the information for this particular problem, we want the net present worth to be at least 0. We want the benefits to be greater than the cost. So we take the benefits, subtract the costs, and we'll bring everything to present day dollars. That's going to be our source of equivalency. Bring everything to present day dollars. So that does the net present worth have to equal or exceed 0? If it will if the benefits are greater than the cost, when the benefits and the costs are both brought to present day dollars, discounted back to present value. So here, one of our benefits is $350 annuity that happens for 8 years. A growth rate, interest rate, discount rate, all means the same thing, of 10%. So $350 is the amount of the annuity. Find P, given A, 10%, 8 years. So we'll go to the interest rate tables, the 10% table, and find that factor in the PA column on the 8-year line, find that factor, and multiply it by the amount of our annuity, $350. We have another cash flow in, another benefit, and that's what we're looking for, the future salvage value or selling price of this asset. That's what we're looking for, find S, right? We want to bring it back to present day dollars. We want to bring that future amount of that selling price in the future back to present day dollars. So everything is stated on present day dollars. So find P given the amount of this future cash flow, 10%, 8 years. That's all the benefits that we have. We have only one cost then, and that is the initial cost of this asset. If we were to buy it today, it would cost $2,000. That's already in present value terms, so we do not need to multiply that by any interest factor, by any factor from the interest table, because it's already in terms of P. We do need to bring these other cash flows back to terms of present value. So we do need to multiply each of these cash flows by an interest rate factor. This one already is in P, so we don't need to do that. Okay, and then just solving, we want to solve for S here, right? That's our one equation, one unknown, solve for future salvage value, future selling price. So 350 annuity times the factor from this table is 5.335 plus future salvage value times this factor, PF column, 10% interest table, 8 years, we get this factor, minus $2,000 initial cost. We're just solving for S. Algebraically, works out to $285 is the minimum future selling price of that asset, such that if we sell this asset out in 8 years' time, if we sell it for $285 or more, then the economic benefit realized from these cash flows in, the benefits will be greater than the initial cost. So that's our minimum required selling price. Answer choice C. And that's the strategy for solving 15.19.